This is home, the only place we know that breathes. For centuries, we've looked up wondering if life exists out there. Watching, waiting, breathing, like us. We may never meet it face to face, but what if we could? Smell it. A whisper in the starlight, a chemical trace in the wind of another world. How do we find life in a universe we can't touch? What is life without being seen? We're not looking for alien cities or radio messages. We're looking for imbalance. Molecules out of place, gases that shouldn't coexist. We call them biosignatures, chemical hints that something is alive. On Earth, life transformed the air. Oxygen wouldn't exist in our atmosphere if photosynthetic life hadn't created it. Add methane to the mix and unstable, reactive gas, and it forms a fingerprint, one that whispers, life is here. Now we search distant planets for those same whispers, using telescopes to split starlight into spectral, like a barcode for atmospheres. Each spike, each dip in light. A rise in oxygen, a trace of methane, maybe something even stranger, industrial chemicals, chlorophyll analogs, or exotic compounds. Anything that suggests not just chemistry, but biology. We're not hunting aliens. We're tracking imbalanced life's cosmic signature, hidden in the breath of distant worlds. In the vast gallery of planets orbiting distant stars, most are uninviting. Some are scorched, tidally locked, bathed in radiation. Others are frozen, trapped in the dark, far from any warmth. But in between lies a narrow path, a zone of potential, where starlight is gentle enough for water to flow, not boil, not freeze. Astronomers call it the habitable zone. It's not a line you can draw with precision. It's a range, a ribbon, a tender zone of compromise. Not too close to the star where oceans boil and skies are stripped away. Not too far where water freezes into silence. But even distance alone cannot make a world livable. A planet must hold its own, needs the right mass, the right atmosphere. Too little pressure, and water simply escapes, vanishing into space. Too much, and heat becomes a trap, a greenhouse prison, like Venus. Habitability isn't a destination. It's a delicate equation where gravity, chemistry, and chance strike a rare accord. And still, we've begun to find them. Worlds that walk that line, balanced between fire and frost. Thanks to the patient eyes of Kepler, the surveys of TESS, and the deep gaze of JWST, we've now cataloged thousands of distant planets. Orbiting suns small and vast, fairy red dwarfs and golden stars like our own. Some are rocky, some are watery. Some turn with gentle rhythm in their orbits, neither racing nor dragging behind. Many rest within that golden band of possibility, bathed in steady warmth, kissed by starlight. We look to systems like TRAPPIST-1, a family of 7 planets, huddled close to a small, quiet star. There, TRAPPIST-1e may cradle an atmosphere, a sky, maybe even oceans. We look to Kepler 186f, the first world ever discovered, Earth-sized and poised in the habitable zone of its star. And we look to Proxima b, the closest exoplanet to Earth, hidden in the glare of Alpha Centauri. It is invisible to the eye, and yet it may carry winds, clouds, rain, possibility. We don't know if any of these planets are alive. We haven't seen rivers or heard signals, but we know they could be. And for now, that's enough to keep us searching. When we imagine alien life, we often look outward, toward distant stars and far-flung exoplanets. But some of the most promising places to search may be right here, within our own solar system. Not on planets, but on moons. Icy worlds orbiting giants. Far from the warmth of the sun, and yet somehow, still alive with motion beneath the surface. These are places like Europa, a moon of Jupiter, its surface, carved with fractures, like veins frozen in time. Beneath that crust, a vast global ocean, kept liquid not by light but by tidal force as the gentle flex and grind of gravity warming it from within. Here, deep in the dark, life could cling to vents, just as it does at the bottom of Earth's oceans. No sun, no sky, just heat, minerals, and the whisper of possibility. And then there's Enceladus, a tiny frozen moon of Saturn barely 500 kilometers across. But it holds a secret. Cracks near its south pole erupt with powerful geysers, jets of salt water, ice, and organic compounds firing into space. We've flown spacecraft through them, and what we found looked familiar, not proof, but something that raises eyebrows and hopes. And farther still, in the deep cold shadow of Saturn, lies Titan, the only moon in the solar system with a thick, hazy atmosphere. Its rivers and lakes are not of water, but of liquid methane, alien chemistry, and yet eerily Earth-like in its landscapes complete, with clouds, storms, and shores. Titan may not host water-based life, but it may offer something stranger, a blueprint for life, not as we know it, but as it could be. These moons are not warm. They do not sparkle with cities or signals. They are dynamic, restless, leaking secrets into space. Beneath the ice, they might harbor an ancient silence broken only by the stirrings of life. Light. It travels across the void undaunted, unchanged, until it touches something, and there, in that interaction, it leaves behind a message. This is how we study planets we will never visit. Not with landers, not with photographs, but with starlight, stretched and bent by alien air. When a planet crosses in front of its star, a small fraction of that light slips through its atmosphere, filtering past molecules, clouds, and winds. And that light, when broken down, carries fingerprints. Patterns of color and shadow unique to the gases present. It is here that we listen for life, not with ears, but with optics. Each molecule absorbs light in its own way. Water vapor, methane, oxygen, ozone. Their spectral signatures are subtle, but distinct. A dip in one part of the spectrum, spike in another. Taken together, these patterns tell a story of chemistry, of climate, and sometimes of imbalance. It could be geology, volcanoes, lightning. But if not those, then perhaps something more profound, a forest breathing, a microbial sea exhaling. Life too distant to see, too quiet to hear, yet speaking in the only language the cosmos understands. Light. In the glow of possibility, it's tempting to believe we've already found it. A hint of methane here, a trace of oxygen there. It feels like evidence. It feels like a whisper from across the stars. But science is not built on feelings. For every biosignature we might detect, there may be a dozen non-biological explanations. Methane can bubble up from volcanic rock. Oxygen can appear when light splits apart water molecules, even in lifeless air. Complex organics? They form in the icy emptiness of interstellar clouds. Nature is clever. It doesn't need life to be complicated. This is why science moves slowly, not because it lacks imagination, but because it demands integrity. It's not enough to detect a molecule. We need patterns, multiple signals. We study how gases interact over time, cross-check with models, rule out geologic noise, and ask again, could there be another explanation? Because this question, are we alone, deserves more than hope, deserves evidence. And when we do find something truly unexplainable by any natural process, we won't need to shout. The data will speak for itself, and we will know, not just that life exists, but that we were wise enough to wait for it. In the darkness between stars, we are listening, not for voices or messages, but for imbalance, for chemistry out of place, for the breath of something we cannot see, a hint of oxygen, a trace of methane, the faint, quiet rhythms of biology. Echoing across light years, we may never shake an alien hand, but we may learn in time that we are not alone, not through conversation, but through evidence. Because life doesn't need to call out, it only needs to live. And in doing so, it may already be leaving fingerprints in the light.